So as Kathy said, I am an engineer, so hopefully I don't bore you too much this morning with acronyms and numbers and those types of things. I think I'm actually supposed to try to wake you up as the initial speaker. You know, a lot of my friends, when they heard that I work for Panasonic, they actually think I sell televisions and other electronic devices. That is not what I do. A lot of people don't realize Panasonic has a smart city solutions team that is product agnostic. And so we help projects at the beginning as both a energy and technology planner and then help integrate solutions on the back end. So I've just got to say, I really love my job. I get to work on transformational projects, and I get to go out to Silicon Valley and other places and see what the coolest tech is that's coming out and figure out how do we implement that into our developments to make them truly special. So that's what I do. How many other people love their job? You watching this? I love my job. All right, so Kathy wanted me to speak about just some of the disruptive technology that's out there that we've seen, and unfortunately I can't tell you everything that I've seen. Some of it's very confidential, but I can show you some stuff. So I'm going to walk through a couple of case study projects that we've worked on and show you some of the things that we've done already, and then also walk through some of the things that we're considering on some of our new projects right now. So is everybody excited about that? All right, good. All right, so the first one is called Fujisawa Smart and Sustainable Town. So this was really our entry into smart cities, and it honestly, it began as a complete failure. It was I believe it was a refrigeration factory in Japan that failed. It became obsolete. So we had this land and we're wondering what to do with it. Panasonic had heard people start to talk about smart cities, but couldn't really find a true smart city anywhere. So actually took a little bit of a gamble and decided to let's just build one of these things and show people what it can really look like. And this is real. This opened a couple years ago. You can go see it. It's a little bit south of Tokyo, about 1,000 home community. Complete smart development, very holistic. You can actually go see it, touch it, feel it, and understand what a smart city is. So I'm going to walk through some of the things we did at Fujisawa. And the first thing I want to say, and I think this is actually the most important thing, is that it's not all about technology. If you want to do a smart city project and your first focus is on technology, you're probably going to fail. It really has to start with intelligent planning. So the best technology is actually our brains and your brains to plan a development or a city in a smart way from the beginning, and then figure out how to layer in technology later to solve other problems. But don't just throw up a bunch of technology onto a development and think it's going to be smart. It's going to cost more and it's not going to work as well. So Fujisawa, from a resiliency perspective. So you have to remember, not too long ago, there was a tsunami that hit Japan, nuclear power plant disaster. Everybody lost power for a while. You had storm surge. So that was a big part of the planning for Fujisawa, was how do we make it resilient against these types of natural disasters? So you look at the community center. Looks like sort of a bizarre building with stairs that go up to a green roof. The reason it was designed that way was for a tsunami. So when that storm surge comes in, people can actually gather on top of the community center, be above that storm surge. When it goes down, they can go back out into the community. Another cool thing about the community center is it's actually a food storage facility for the neighborhood. So if a disaster suddenly happens, this neighborhood has food and water already stored up. I live in Florida. Kathy, you live in Florida. Kathy, what was it like before Hurricane Irma came through, trying to find food and water? It was horrible. It was horrible. So this really gives residents that peace of mind. They already have it. They're not scrambling to go find what they need to live. Just other little things. The park bench actually converts to a barbecue grill. So if there's a natural disaster, Power plant goes down, need an alternative way to cook, you could actually pull the bench off and cook the food that's stored in the community center and have an alternate way to eat. So good planning. So the technology here was just people using their brains and thinking. Same thing from an energy perspective. Most of the time when you see master plans, it's just sort of pretty boxes on a page to make it look like a cool master plan. I don't believe there's enough thought put into the energy side when you're actually doing master planning. So this is an area that we really believe in sort of front-end loading. So in Fujisawa, every house is actually laid out so that it can capture natural sunlight. Every house is organized so that it can capture sea breeze. So this is actually a really interesting thing to tell people. Panasonic sells lighting and air conditioning. We were actually trying to design those out of Fujisawa. So then, after using intelligent planning, this is where you can start to layer in the technology side. So Fujisawa, every home has photovoltaic power. It's got its own battery storage, and it's basically its own microgrid. So the next time there is a power plant disaster, all of these homes can actually disconnect from the grid and run on their own. They actually have an energy management system that rivals what you see in commercial buildings here. So you can actually see how your building is performing, track your energy use, and really figure out how to stay online if there's no power plant available. Transportation as a service. In Fujisawa, you can go on an app on your phone, and you can figure out where there's a neighborhood bike available. You can have a short-range electric vehicle delivered to your house, or you can have a long-range rental car delivered to your house. You don't need a car. So this is disruptive. So now you don't need a car. You don't need to design a garage into the houses. They still do have some garages, but I think this is a really disruptive technology in sort of how we design homes and neighborhoods when you start to have shared car services. And we're starting to see some of this in the US as well. How many people like waiting at the doctor's office? Raise your hand. I think it's the worst thing in the world. It's like the best place to get sick. So in Fujisawa, we did a lot of planning from a health perspective, and really the goal is to keep people out of the doctor's office. So from a planning perspective, real simple thing, the assisted living elderly care is actually co-located with the daycare. Reason being is now we can start to have some knowledge transfer, some wisdom go from one generation to another so that the kids don't do stupid things that I did as a kid. They actually learn from their elders to try to keep them out of breaking their arms and things like that. And then also telehealth. So in Fujisawa, you can actually do a doctor's visit through your television. You don't have to go anywhere except your living room, and you can actually communicate with your doctor. And where this is really starting to go are into wearable technologies that, I've seen this, I can't say much more about it, but I've actually seen a t-shirt that has sensors embedded into it. So normally if you go to a hospital, they start clipping all these things on you. There are now clothes that can actually do all that same sensing. So if we start to embed these sensors into our clothing, now we can start to communicate with our doctor remotely without having to go to the office and get all plugged in and then do a telehealth visit. And so that book, if you want to read more about how the healthcare industry is changing, that's a great book. I actually got that from a senior person with a big healthcare facility that they really believe telehealth and all sort of these sensors embedded in the home is going to transform their business. And so they don't want to be disruptive. They want to sort of plan for it. And the title of the book nails it. The patient will see you now. You're not waiting on the doctor. The doctor is actually waiting on you to log in, upload your data, and then do your visit. And so the results. I know this is a sustainability summit, but the biggest part of these results was the money side. The homes in Fujisawa, so this was a big win for us. The homes in Fujisawa are selling at a 25% premium over similar homes that are literally across the street. So this is what made us realize this isn't just about trying to save the planet. It's the right thing to do as a business. And this really sparked us to create a smart city team here in the US. This is the economic side. So we started a smart city team here in the US, and it's called City Now. And to launch it, we, again, similar to Fujisawa, a lot of people are sort of talking about smart cities. We said, if we want to be legitimate, we need to go build one. That's how we need to start. So we invested in 382-acre mixed-use development in Denver. So we're part landowner and developer with a couple other partners. And actually opened our operating center for our smart city team there. Have rolled out a lot of the smart city tech already, and about to break ground on an apartment and a hotel basically right next to our office. But right now it's a train station on the light rail line, our office, and some smart city tech that you can actually go see and touch and feel already. So I'm going to walk through some of the tech we're rolling out there. Maybe. There we go. How many people have heard of dark fiber? Sounds cool. So this is actually a disruptive technology to traditional internet service provider models, where the ISPs come in, they put in the fiber, and then you're sort of stuck under their control. So Peña Station is sort of a partial dark fiber development. We're starting to see other developments that are all dark fiber. So the community is actually buying the fiber and then charging the internet service providers to ride on their fiber so that they are not controlled by those companies. So this is a big part of master planning that a lot of people are starting to analyze. Smart streetlights. It's amazing how much technology you can cram onto a streetlight. So most people look at a streetlight now and it's just a dumb light. But streetlights are really going to become the eyes, the ears, on the ground for a city or a development. So environmental sensors. I'll give you an example in Denver. In Denver, when it snows right now, I mean, they literally roll out every single plow because they do not have eyes and ears on the ground or the right temperature sensors to actually understand where they need the plows, so they have to roll them all out. So one of the things we're testing is temperature sensors, below grade, at grade, and above ground on a streetlight with cameras, so that the city now understands, do I really need to roll out all 100 whatever trucks we have, or can I only roll out 3? And this is like a $100,000 decision every time they roll out these trucks. So it's trying to help them do it in a more intelligent way. All kinds of, I could spend all day talking about streetlights. It seems boring, but I could. But one of the biggest things is, as you start to embed all these technologies and sensors into the streetlights, how do you sort of package it all together? And right now, most cities or developments, they have all these separate systems for security cameras, separate systems for lighting control. So one of the keys is to really try to integrate it all together into one pane of glass so that the city can actually manage it. And what we're starting to test now is, how can the city systems communicate with my private building systems? And there are limitless applications when you start to think this way. So for example, if you have gunshot detection on a city streetlight, and somebody shoots a gun, streetlight sensor notices that, through an open platform, we can actually send information to a building like this, make an automated PA announcement, lock the building down because someone has fired a gun outside. So all kinds of cool things we can do when we start to get buildings and cities to talk together. Cameras. This one's a little bit scary to me, but I think it's scary in the US. People are sort of worried about Big Brother, but the reality is you are on camera most of the time. So now it's, do we want to put intelligence into those cameras so that they become a more powerful tool? The one I don't like is we can actually, where people are doing this already, you can use them for retail. So if I walk into a building and it's an intelligent camera, it knows I am a 41-year-old overweight man, and it can start to change digital signage to direct me to different areas in a store. Can do it already. I don't like that one. But other things, I mean, facial recognition. So think about if you say you have a restraining order against somebody, and they walk into your apartment complex, and facial recognition actually picks them up as they walk into the building. Automated call to law enforcement might actually prevent a major crime from happening. So the camera's already there. Now it's about putting in intelligent cameras. Same thing with analytics that we can do with cameras. We can detect suspicious movement. We can tell, people from animals. We can tell if people have crossed into an area where they're not allowed to go. So we're doing a lot of things with intelligent cameras. Autonomous shuttles. So a lot of people ask, when are autonomous cars really going to be here? They're already here. We have one in our neighborhood. It looks like a toaster, a 12-person toaster, and like those doors open and people just pop out of it. And it's interesting because we're a bunch of technology people. We like to test it out. So I think the software company behind the autonomous shuttle kind of hates us because our employees are always sort of jumping in front of it to make sure it actually works. But they're here. You can do autonomous shuttles. And the big thing here is solving the first and last mile of mass transit. And so actually, we're not just putting an autonomous shuttle in our neighborhood because it looks like a cool toaster on wheels. We're doing it because the bus stop and the train station are about a mile away. So if it's a snowy, cold day, people are going to decide, I'm just not going to take mass transit because I don't want to walk that mile in between. So we're trying to solve that with the shuttle. We also have hotels that are outside of our neighborhood that are within a mile or two that the bus service doesn't go to. But all the hotels sort of have these private shuttles. So you got this van that holds 20 people, and they usually only have one passenger in it. So we're trying to create sort of a better system for doing that with one electric autonomous shuttle as opposed to 15 gas-guzzling shuttles. Vehicle to everything software platform. So this is one area where I'm really proud of the team we have working on. How many people know someone that's died in a car accident? The goal of where we're going with vehicle to everything technology is to eliminate most of those deaths. In a couple years, it is going to be mandatory for new cars to have vehicle-to-vehicle communication. So your car will be able to talk to a car that's 200 feet, 300 feet in front of you. So, and cars have an unbelievable amount of data on them that a lot of people don't even realize. So, for example, say you're 200 feet behind someone, all of a sudden their tire pressure goes down. They ran over a nail. These systems are going to allow that to communicate to your dashboard. So you'll actually get a signal as their tire pops. Hey, watch out! The car in front of you is their tire just something went wrong. You might want to slow down now. So that's part of it. The other part is now how do we leverage that data from a bigger picture as opposed to just the two cars talking? And that's something we're working on with Colorado Department of Transportation and actually rolling this out onto I-70. So now imagine you're driving in the middle of the night, there's no one else on the road. For whatever reason, you swerve, you crash, you get knocked out. The police are not going to come if there's no one there to call. But through software, we can actually now see that an airbag has deployed, a car has rolled over, and they can be automatically alerted. And even if someone does see it, sometimes life or death, it's just a couple of minutes. So if it takes them a couple of minutes to make that phone call, to get everything going, that might be the difference in whether or not somebody lives. So this just makes it automatic. Cool stuff. Carbon neutral planning. Looks like a fun diagram there. So this really kind of gets back into that intelligent planning perspective. And what we're doing right now is something that I don't think anyone else in the country is doing. And this is in partnership with Xcel Energy and NREL, National Renewable Energy Labs. Xcel Energy is the power company. What we're actually doing is creating a new process of how to link development and building energy modeling with utility distribution modeling. So we've actually built energy models for what we think all the future buildings are going to be in our development. We've actually merged those together into one holistic development energy model. We have the utilities model of their substations, power feeders, and we're actually looking at how those interact together. So as we start to drop, building energy by 3%, how does that impact the utility feeder? So this is huge because we're trying to find the optimal point where the utility doesn't have to put in a new substation. The utility doesn't have to upsize their feeders. And so now the utility is looking at, boy, if I don't have to do these things, what else can I do? What my customers want clean energy, they want resiliency, now I can invest that somewhere else. And we actually think through this process, we are going to unlock a way that a lot of communities can do carbon neutral without it costing more. And some of the reason behind that, anybody here work for an electric utility? No one? I'd have them explain this. They'd probably be better than me. But most electric utilities actually have a very bad business problem. As we've implemented energy codes over the years, we've gone to LED lights. What's happened is the kilowatt hours that they're selling you has actually been pretty flat. The utilities actually look at energy codes. They call it kWh erosion. It's revenue erosion for them. They are not making more money. But the other problem they have is that the demand is actually going up. More buildings are putting in air conditioning. And so demand is how much power plant they have to have. So they need more power plant, but they're not selling you more power. So their upfront costs are going up, but their revenue is staying flat. That's a business problem for every utility. And so most utilities realize that one of the solutions to that is battery storage. And we actually think batteries are going to play a huge role in the future of buildings. So that picture over there, that's actually the 2 megawatt hour battery in our neighborhood. We are on our own microgrid. We can actually disconnect our whole neighborhood from the rest of the utility. And that battery is actually owned by the utility. And so this is another lesson I want you to hopefully remember today. It's not about technology as much as it's about partnerships. So by partnering with the utility, we actually avoided putting in a standby diesel generator at our building. We saved money on our building. The utility is using this battery to help with their demand issues and avoid putting in a new substation. And we are actually going with the utility before the Colorado Public Utilities Commission to argue that there should be a new rate structure around resiliency, and we're willing to pay more for it because we avoided CapEx costs of a generator, and our building will never go offline from a power perspective. If something goes wrong, we disconnect from the rest of the utility. I've got 2 megawatt hours sitting right outside my building. I can run all day long off solar and battery. Fully resilient rate structure. So partnerships and really trying to create new business models with utilities, with cities, that's what's going to unlock doing some of this technology, in our opinion. Building apps. How many people have seen either of these apps, Comfy or Crowd Comfort? Cool. So we're testing out all kinds of building apps, and I'm not trying to sell you these. I don't make any money selling products, but still had to show their names to give them credit. So Comfy is an app, so all of the employees in our building can actually vote whether they're hot or cold on their phone, and it actually adjusts the air conditioning system accordingly. Pretty cool. Crowd Comfort, it's basically an asset management app, so you can report any issues with the building. So say Kathy spilled coffee or broke the chair, she can actually take a picture of it, report it to facility staff. They actually get the picture on their phone. They know what Kathy broke, so they know what tools to bring. It actually saves them time. Why? So I think building apps, and I'll talk about this a little bit more later, are something that you're going to see a lot more of. And we're testing those. So that's what we're doing in Denver right now. So now I'm going to jump into some of the tech we're looking at for our next projects that we're working on right now. So everybody still awake? Raise your hand if you're awake. Cool. A couple people didn't raise their hand. I'm a little worried. Should I take questions now or wait till the end? Cool. So one of the things, and this is actually another thing, so when we work on smart city projects, we think a big thing is to know that technology is going to change. And so you should actually plan that in. So in Fujisawa, we actually have a home that's called the Wonder House that is strictly a model home where if a new technology comes out, we can actually test it in that home, and if it works, we roll it out into the rest of the neighborhood. Peña Station is the same thing. It's a big living lab. So we are constantly looking at new technology from startups and wherever to see if there's something else out there that might improve our neighborhood, and then we test it in this neighborhood, and if it works, it can then be rolled out to the greater city or our other projects. So this is some of the stuff we're considering both for our Peña Living Lab and some of our other smart city projects. So space management is pretty high tech. This is huge. You know, everybody's seen sort of the tiny house movement, is hearing about micro apartments. So really sort of making that more mainstream really gets into intelligent space management solutions. And again, we're a company that sells lighting and air conditioning, but we're looking at space management as a way to make an apartment or a home actually smaller. And once we start to make the footprint smaller, it doesn't need as much lighting and air conditioning. It's a big focus of ours. Smart parking. How many people have ever gone to a concert and you like wait in line for 30 minutes to get into the parking garage, and then when you get to the parking garage, you realize it's full? Has anybody done that? It sucks. So we are looking at some very intelligent parking solutions, and again, this gets into partnerships. And what we're actually trying to do here is drastically reduce the amount of parking in each building by networking all of the parking within a city together. So I can't say where we're doing this right now, but we are working on a development project, and we are trying to partner with the city to actually roll out smart parking in our garage and smart parking in the city garages, so that when you pull up to our garage, if it's full, your phone will actually notify you that it's full well before you get there. It will direct you to a city lot. It can even direct you to a level or a specific space within a city lot that we can reserve for you. And then we can go pick you up with our toaster, the autonomous shuttle, and bring you back to where you need to be. So, you know, most cities, you know, people, you know, think that the parking is terrible, but in reality, most cities have way more parking than they need because the parking infrastructure is not networked together. And we can actually solve that with technology. Maglev trains. So there are some high-speed maglev trains that exist already. Extremely expensive. We've actually been talking with a company that does a suspended maglev because you can actually do that at a much lower cost. This is actually another lesson. There are a lot of companies that will tell you about technology, and then when you dive further, you realize they're full of it. In this sort of suspended maglev world, there's several of those companies, and I won't name names. But we think we found one that their technology can work. And the other thing that they're doing is, I mean, you think about a train, it goes from, it's a fixed linear route. So you may still have to walk a mile afterwards. You may have to stop at 4 stops in between that slow the train down. So we're actually looking at a networked, suspended infrastructure, so almost like roads, but up high with maglev trains, and we're looking at a development in Colorado to potentially implement this and partner with the local transportation district. Lighting as a smart building platform. How many people have seen this or some of this? Anyone? How many people are architects here? Do you guys like all those things on the wall, the thermostats and the CO2 sensors and the ox sensors? That you don't like them, do they? Do you? And what happens right now is all of those sensors are typically completely separate systems, so they're not integrated. So they're running wire. You know, a different company is running wire to all of those. I'll be honest with you, I've done a lot of retro commissioning. A lot of those sensors don't even work. They're out of calibration, they're broken, and people just don't know it. So a lot of companies right now are starting to embed the entire sensor network within lighting because it's a natural node. We're not, you know, you're always going to have lighting in buildings. There's already power to the light. And what's really cool about it is it's on a network. So if I embedded sensors into 5 or 6 of these lights, I can actually start to self-calibrate. So if one sensor fails and is different from the other 4 sensors, you can notice that, and you can sort of kick it out of a control loop, or if there's a way to sort of recalibrate it automatically, you can. So what we are seeing is that the lighting systems are going to take over the controls of buildings, and this is multiple companies that you'll see doing this. Big companies like Philips and Acuity, really trying to put all of the sensor network into the lighting system and really make the lighting system the driver for the building. And instead of having a bunch of different separate systems with separate sensors, the lighting is actually going to drive all the other systems. And there's a lot of other cool things you can do with it. So one of those is indoor positioning. So right now everybody has GPS on their phone, and you use that to figure out how to drive from one building to another. But when you get inside a building, that doesn't work. It's not granular enough to work inside of a building very well. But when you start to put Wi-Fi beacons or Bluetooth beacons or RFID beacons embedded in the lights, which is actually really cheap to do, you can now do indoor positioning inside of a building, similar to how you do it driving around the street. So really cool applications with this. Again, there's sort of the scary retail version, similar to the cameras. Now they can actually track that I'm in the building and there is actually a company working on this, that as you walk into their retail store, it knows it's you, and if it knows you like Star Wars, it'll actually change the digital signage and point you to that direction of the store, because they will get more retail dollars out of you that way by getting you into the spot where you want to spend money. But there's other great applications. Space utilization, that's actually what that map is. So you can start to map how the traffic is occurring in the building. So now you can actually predict, where's the carpet going to wear out first? Or it shows that Kathy hasn't been in her office for 2 weeks. What is Kathy doing? There's a printer that no one ever uses. Why do we have it there? Why don't we move it somewhere or get rid of the thing, because it's just drawing power and no one's using it. Asset tracking. So think about a hospital application or a lab where they've got equipment or wheelchairs that somebody can't find at a critical time. Through indoor positioning, you can put a tag on that device, and you can actually locate it in the building within a couple of feet. Wayfinding. We're actually talking with the company that made this image and Lighted about doing wayfinding for the blind. So a blind person can walk into a building, and their phone can actually talk to them, take 10 steps forward, hang a left, to guide them through a building in a better way. So all kinds of stuff you can do. I can talk about this one all day. Life safety. So think about if there's a fire in a building, you can actually, through lighting systems now, you can do this now. You could actually show that there are 3 people in the northeast corner of the building. That's where the fire department needs to go. All right, LED communication. So again, this sort of gets into what we can embed in lights, but this can also be embedded into screens, LED screens, televisions, that can actually communicate with your phone. So if you're at a football game and you see something on the Jumbotron that looks really cool, you can actually point your phone at it, and it will send you more information about what you specifically just pointed at. It's fun stuff. Voice command. How many people have Alexa or Google Home? It's pretty cool, right? But it's kind of a do-it-yourself product right now. So there are a handful of companies that are trying to figure out, how do we do that in a commercial building? How do we do that on a bigger scale? Does it get embedded into the lights? Is it a separate system? And how does that all sort of integrate within a building so that you can walk into your office and say, I'm hot or I'm cold. You don't even have to open the app on your phone. You could say dim the lights. So I think in a couple years, maybe even sooner, you're going to see this on a commercial scale that goes beyond what you see with Amazon and Google right now. And it's something we're looking to implement. And so one of the other great things about LED lights is, because they don't use as much energy as they used to, now we can power everything low voltage, or most things in a building under low voltage. So many, many years ago, when electricity was invented, AC power beat out DC power and became the standard in our buildings. So all of our buildings pretty much operate on alternating current. But most of the devices we use are actually direct current. So what's happening right now is renewable energy produces DC power. We then transform it to AC power. My computer and my phone are DC devices, so then I have that brick or little cube that transforms it back to DC. So we're transforming power back and forth when we don't have to, and we have a ton of losses along the way. So now that the energy codes have driven down the consumption of all these devices, I think you're going to see more and more buildings that are either low voltage direct current for a lot of the building or power over Ethernet. So now you don't even need to hire an electrician. You just plug in a Cat 6 cable to wire up to power up a light. Anybody been in a PoE building or a DC building? There's only a couple of them. No one? You'll start seeing more. Smart glass. So probably a lot of you have seen the glass that changes tint. That is just the beginning. Once you make a piece of glass, basically an internet addressable device, you can actually do a lot more with it. And some of this I am not allowed to share, but imagine yourself. You have your eyes and your ears and your skin, and you can touch and feel and see all this stuff. But right now, your building can't really do that. You might have some separate camera systems. You might have a separate outdoor weather station. Once the glass starts to become smart, it can become more like us. The skin of your building can become more like a human. And I think you're going to start to see some really cool things coming out of the smart glass world. Smart mirrors. I hate this one. So this is actually a mirror for a hotel room that is a smart mirror. It's like a big iPhone. You can push a button. You can talk to it. I was actually testing it out. I was trying to find a restaurant. I was trying to pick the buffet. And kind of like the camera, it's like, dude, you don't need to be going to a buffet. You need to go to the salad place. So I had a very bad conversation with my mirror, but it's coming. Artificial intelligence. So I mean, everybody throws around machine learning and artificial intelligence and doesn't really know how you're applying it. But one great place is actually with electric meters. So typically, to try to figure out how you're using energy in a building, you have to install submeters all over the place to figure out where stuff's going. Through artificial intelligence, you can now do a meter on a main that uses the AI to actually learn the signature of electrical devices. So you can put a meter on a main panel that might have 50 circuits, and if I turn a printer on, it starts to learn the signature of that device. So this system, we're actually about to install this in our building. We're not using Sense, but Sense is a residential company that does this. So you can put 1 meter on your home, and it can tell that somebody left the refrigerator door open. So it's pretty cool technology and application of AI. And almost done, I promise. Everyone still awake? Raise your hand. Did I lose anyone yet? No, actually, looks like a few people woke up. So I mentioned earlier about some of the apps we're testing. So those apps are sort of very custom and closed. What's actually starting to happen now, and I can't say too much about this, but there are a few companies looking at how can we embed Apple iOS or Android into our building products. So now you can start to customize your building, kind of like you customize your smartphone. So third parties can start to write apps as opposed to traditional building world are sort of very closed energy management systems that all sort of operate under their own programming techniques. So this is a chance for people to actually use an app store to start to write your own apps for your building. So does anybody have like a really cool idea for an app that you want for your building? Anyone? No one? Kathy, nothing?
I'll tell you after.
All right. I was going to steal an idea if somebody said something. Good, but so I think you're going to start to see this in a few years that some of your building systems you'll actually be able to custom program similar to what you do with your phone. So I'll wrap it up here. And I want to go back to about the first thing I said, that I rolled through a bunch of technology stuff, but that's not what it's about. It's really don't provide technology for a problem that doesn't have to exist. Sorry, I'm reading my slide. Start with good planning. If you really start with good planning, you're gonna limit the amount of technology you need, which is gonna make it a better project, and then figure out how to intelligently layer technology on top to optimize what you're doing. And then another big part of it is partnerships. So our carbon neutral, microgrid, fully resilient neighborhood in Denver, we could not have done that alone. The utility could not have done that alone. Denver Airport's actually involved in it as well. They couldn't have done it alone. It actually took all three of us partnering and creating new business models for each other to make it financially viable. And then last but not least, all this stuff is going to change. There are a million new technologies that are coming out, and so you have to embrace that. You have to plan for that. Think about do you want to make a living lab or an innovation center to sort of test these things as you're building out your own smart development or smart city. So that's it.
Thank you, Mike. Am I on? Okay, we're going to take a few questions for Mike, so if anyone has a question, raise your hand. I'll turn the mic over to you.
The 2 megawatt hour battery pack that you showed, what's the technology for it? What is the expected service life for it? And can it be used as a UPS, an exterior package as a UPS for a building?
They're lithium-ion batteries. That's the technology. So it's a bunch of little lithium-ion cells glued together into a huge battery pack. The switching is not quite there yet at the utility scale for us to sort of look at it as a full UPS. So we still have smaller UPS battery in our building for that glitch between when we island ourselves from the rest of the grid. So, the couple of seconds that it takes that switch to cut over to our backup power and island our microgrid, we have to account for that with some smaller batteries in our building. But I think it could get there eventually.
And the service life?
I am not a battery expert. Not sure what it is, but I think it's over 10 years. And that's actually one of the things we're also looking at is in the building world, you don't need the best batteries. So we're actually looking at taking batteries from cars that have been used for 3-4 years in a car. When they start to lose their power, your car doesn't accelerate as well, so they don't want them in cars, that we can actually take those batteries, recondition them, and then use them for a longer time. So it really sort of stretches out the service life of a battery for a building to be longer than batteries in other applications. But I can ask our battery geeks the number if you really want it.
Thank you. Yes.
I have very practical pedestrian questions. So if we introduce this wireless supply of energy, which basically you use without any circuits, without any wires, how do you measure consumption? How is that possible?
It's not completely wireless. You're talking about direct current or power over Ethernet?
Yeah, I'm just talking about, I think there were ideas before that you can have wireless supply of electrical energy, and the main problem was you cannot measure how much energy has been used.
Well, in a lot of cases, when you're powering something over an Ethernet wire or direct current, the power consumption is so small, it's almost not worth monitoring, but you still monitor at a bigger scale. So you might, if you did a direct current ceiling system, you could monitor that whole ceiling, and through artificial intelligence, you could potentially start to learn what devices are on.
Device by device.
Yeah.
I've got an app idea for you. You can take this. Sean Casey with AECom right here. Maybe in a building with many floors, as you're walking to an elevator, have that elevator call to your floor and have it open with the doors. So you can take that one if you want.
People are working on that.
Yeah, nice. So my question is just about how you assess all these different technologies. And say you're working with a client and you're looking at different benefits and different interactive effects. how have you found is the best way to sort of assess all of those and then talk about it with the client and agree on a set group of technologies?
I mean, honestly, it starts not by thinking about technology, but by asking the owner what's most important to them. Like, what are they really trying to do? Is it carbon neutral? Is it, autonomous vehicles? Like, what are sort of their important things that they think will make it a smart community or a smart city? And then we, just based on our experience, we start to look at specific technologies that we think may help with their issue.